This video is a quick run through of the final preparation that you need to be doing before your GCSE Chemistry Paper 1. Hopefully by now you've finished your major revision and you've had a chance to watch my video with a summary of all the content that's in this paper. So this is really about what you want to be doing right before you go into the exam and also in the first 5 minutes. Hopefully you're watching this far enough in advance to be able to put into practice some of the suggestions I've made, but even if you haven't got time, the techniques I suggest here are going to help you to perform at your best. You'll have noticed that your exam paper tells you to bring a black pen, a ruler and a calculator. The black pen is important because your paper is going to be scanned, not hand delivered to your examiner, and black pen scans best. The ruler can be used for measurement questions where you're asked to work out a scale, and although some pupils think that they don't need a calculator for the chemistry paper, you need to remember that 20% of the marks on this paper are for mathematical skills. If you've made it to school without any of these things, go find your science teacher, or if you can't find them, find your maths teacher. They're still an adult who cares about you and they still want you to do the best that you can. Don't wait until you're in the exam because the invigilators may only have limited supplies to lend out. You should also make sure that your calculator is in the right mode and that it's giving you sensible answers. So just do some quick calculations and make sure that it's not giving you any error messages. For the GCSE exams, you get a minute per mark plus 5 minutes spare. That means you can afford to spend 5 minutes at the start getting yourself straight, scribbling down some thoughts and having a quick flick through the paper. You don't need to dive straight in. It's worth having a hit list of things that have a high likelihood of coming up or that you know you often struggle with, and in the first minute of the exam you can write these down. For chemistry, you have the periodic table that you can write on, so we can do a little bit of annotation of that periodic table and then also write down some other things that you think you're going to need to remember. In both of your GCSE chemistry exams, you're going to be given a copy of the periodic table, and this contains a lot of really useful information. It's worth taking a minute at the start of the exam to annotate it with key things. So I always say to my classes, when you go into the exam, you're going to be feeling really positive because we've just done our final prep session. So starting at the top left, because that's where we start when we're reading or writing, you're going to draw me a nice plus sign because you're feeling so positive. And then you're going to feel even more positive because you've done what I've told you to. So next you're going to write 2 positives. The idea of this is that it's helping you to remember what kinds of ions are formed by the elements in this group. Now at the very end of the exam, you're going to be feeling completely empty. So we write a 0 to remind ourselves that the elements in group 0 are not going to form ions. And then to make the whole thing look kind of symmetrical and matchy, we're going to have a minus sign over group 7 and 2 minus over group 6. The next thing you're going to think about is where in the periodic table you find different kinds of elements, because this is going to be important both for talking about metals and non-metals, but also for getting into some of the bonding questions. So even if you're struggling to remember which side of the metals and which side of the non-metals, there are definitely some elements that you're not going to forget. So find them. For instance, you know that oxygen is not a metal, and you know that things like iron or copper and silver and gold are metals. So find them on your periodic table and write yourself a little reminder. This way you always know that metals are on the left and non-metals are on the right. Then look at that really helpful key that the exam board have given you. At the bottom, where it says atomic number, they literally put the word proton in brackets. So when you're asked how many protons a particular element has, you just need to look at that bottom number, that atomic number. You can also remind yourself that as long as you're talking about atoms, the number of protons will be the same as the number of electrons. Then you've also got the relative atomic mass for each element at the top. And this is what you're going to use for all of your other calculations, all of that quantitative chemistry, like working out relative formula masses or percentage by mass or yield. And I would annotate that onto your periodic table before you start so that in the heat of the moment, if you panic, you remember which number you need to be looking at. Now that you've spent literally 20 seconds annotating your periodic table, flip that piece of paper over and scribble down some of the key things that you've just been saying to yourself over and over in your head on the way in. If you've got the time beforehand because you're watching this video maybe a week in advance, I would really strongly recommend sitting down and deciding what are the 5 key facts for each paper that you're going to need to remember. Now I'm going to put a lot more on this slide than I would expect you to write down because I want to give you some ideas for key things that you might be struggling to remember or that might be very useful in the exam. Remember, there are lots of marks for working scientifically things, and often people don't revise these as well because they're really focused on the content. So one thing that you might really need to remember is what the variables are, because for any of the required practicals you could be asked to name them. I can't remember who on Twitter I stole this from, but for the last couple of years I've loved using the acronym MIXDRY. So this stands for the thing that you modify, so the thing that you change as the investigator, is the independent variable, and on a graph that goes on the x-axis. Whereas the dependent variable is the thing that you record, so you're changing the independent variable and then recording what happens to the dependent variable, and that goes on the y-axis. And then I always tell classes I'm a control freak, so I like everything to always be the same. I always have the same kind of PowerPoint, I always have the same seating plan, because I'm a control freak. So your control variables are the things that you are forcing to stay the same. It's always worth having some of the little conversions. So for instance, there are 1,000 milligrams in a gram and 1,000 micrograms in a milligram. And for the chemistry paper, particularly if you're taking the separate sciences, it's worth writing down there are 1,000 centimetres cubed in a decimetre cubed. Two terms that pupils often also get confused are repeatable, which means that you're doing the same investigation in the same way and you're still getting the same pattern, even if the results aren't exactly the same, and reproducible, which means that either another group of scientists are reproducing your work, or it could be you doing the same kind of investigation but with a slightly different method, and again you're still getting the same pattern. Now, in terms of things for each different individual unit, you really want to think about what are the things that you've got wrong in the past, or what are the things that are very likely to come up. So as I say, there's going to be more here than you could possibly write down in the time that you've got, but these are a few key things that you might want to add to your list. So one mistake I often see pupils making is where they talk about charges. If a question asks for relative charge, it needs to be a number. So explicitly writing down that the relative charge of a proton is +1, not just positive. Another thing is this idea that as you go down group 1, the elements get more reactive, but in group 7, it's the other way round. So as you go up group 7, they get more reactive, and fluorine is the most reactive of all. For the bonding topic, you might struggle to remember which kind of bonding is found in which bit of the periodic table. So for instance, it's helpful to remember that for ionic bonding, you need those two kinds of ions. You have those positive and those negative ions. So that means you're going to need both metals and non-metals. Another really common mistake that comes up is when people are discussing simple molecular substances, so things like water or methane, melting and boiling. And needing to remember that when these substances melt, it's the weak intermolecular forces that are overcome. It's not the strong covalent bonds that break. For quantitative chemistry, maybe you would want to write down some of the different formulae to remember. So for instance, mass is relative formula mass multiplied by the number of moles, or possibly the two formula for concentration. Although you might find that because you're given the units for these, like grams per decimetre cubed or moles per decimetre cubed, you can work that out without those formulae. For chemical changes, I would probably be thinking about the required practicals, and that's a really good place to start from when you're forming these lists for any of the papers, because the required practicals are more likely to come up than anything else. So you might want to write down the formula of the 3 strong acids that could be used to make a soluble salt. Or you might want to write down some tips for the method. So the idea that you heat it to speed up the reaction, you add excess base to make sure that all of the acid reacts, and you filter to remove that excess base. You might also want to remember some of the general formulae for how different substances are made. So for instance, MASH stands for metal plus acid reacts to form salt plus hydrogen. And then you can edit that as well. So we can have, if a metal oxide reacts with an acid, then instead of making hydrogen, we make water. And if a metal carbonate does, then we make that water, but also carbon dioxide. Another topic in Unit 4 that students often struggle with is electrolysis. So you might want to write yourself a reminder of oil rig, oxidation is loss, reduction is gain. Or a reminder that a cation carries a positive charge. Or a reminder that reduction always happens at the cathode and oxidation always happens at the anode. For Unit 5, you might want a little reminder that exo is like exit, it means giving out, so giving out energy, which is going to heat up the surroundings. Or something about the required practical, maybe something about the different variables or the fact that you need to measure temperature change. Or for bond energy, if you've been using bendo-mexo, so breaking bonds is endothermic and making bonds is exothermic, that could be a good thing to write down as well. So you've now spent maybe 20 seconds annotating your periodic table and another minute or so writing down the 5 key facts that you've been holding in your brain on the way into the exam. You can now take the time to have a quick flick through the paper and see what topics are going to come up, paying particular attention to the 6-mark question so that you can have that ticking away in the back of your brain while you're answering the rest of the paper. One final thing to mention. Around the outside of your exam there's a border and it says not to write outside of it. Again, this is because your paper is going to be scanned, and if you write outside of that box it may go off the screen. If you run out of room and you carry on into some white space, that's okay because your examiner can see what's happened and there's a button that they can click which will show them the whole of the page, even if you're not writing in the specific answer space for that question anymore. But if you make a mistake and then you don't cross out your answer and you just start on a different bit of the exam paper, your examiner won't know what happened. So it's really important that you don't do this. This isn't like a mock exam where your teacher has the whole paper. So if you do find that you've made a mistake, what you need to do is put up your hand and ask one of the invigilators for an extra piece of paper, and then they will fill in a special form, which means that the exam board know that you've used that additional paper and your examiner will still have access to your full answer. Thank you very much for watching, and I hope that you're now feeling slightly more prepared for your GCSE Chemistry Paper 1. Good luck with your revision, and if you did find this useful, don't forget to like and subscribe for more GCSE Chemistry revision videos coming soon.